Well, we've looked at the perpendicular bisector theorem and the converse of the perpendicular bisector theorem, as well as the circumcenter theorem. And now we're going to attack the angle bisector theorems. And then a little bit later on, we'll look at the incenter theorem. But right now, we're going to deal with the angle bisector theorem. So we got a diagram here on the right, and it says that if the measure of BAC, so we got BAC, that angle right there, is 38. So we're given that that's 38 degrees. And BC, this segment here, is 5. And DC, this segment is also 5. Find the measure of DAC. Now, according to the converse of the angle bisector theorem, it states that if a point is on the interior of an angle, well, this point C right here is on the interior of the angle BAD or DAB, and it is equidistant from the sides of the angle. Well, this point from here to here is 5, and from here to here is 5. In other words, CD and CB both are 5, or BC, DC, both 5. Then it is on the bisector of the angle. Now, if it's by the bisector of this angle here, by definition, then, and if angle BAC is 38, then by definition, I'll put this in a different color, DAC is also going to be 38 by the definition of an angle bisector. All right, that's pretty cool. So take another look at something else here, and we'll keep moving along. Okay, so we got the same diagram over here to the right. And so this time we're saying that if the measure of angle BAC, so BAC is right here, and if that is 40, and the measure of DAC, put this in a different color, DAC is 40. So there's DAC, measure of angle DAC. And DC is 10. Find the measure of BC. So if we got a point, angle bisector theorem states that if a point is on the bisector of an angle, so again, we're looking at point C, it's on the bisector of the angle. We know this because BAC is 40 and DAC is also 40. Tells us by definition that that line that's passing through points A and C is on the interior, and it is bisecting that angle. Then it is equidistant from the sides of the angle. And so therefore, since point C is on the angle bisector and DC is equal to 10, then BC must also be equal to 10 based upon the angle bisector theorem. Pretty cool, pretty cool. Now we'll do a little bit of calculation on the next slide. All right, same diagram. We're going to dissect it a different way. It says if ray AC, so here we got ray. We've got the endpoint here. It's passing through C. We see it's going on out to infinity somewhere, so it's a ray. If it bisects angle DAB, so it's bisecting this large angle here, and BC, this line here, is equal to 4x plus 8, and DC is equal to 9x minus 7, find BC. Now, once again, according to both the bisector angle theorem and the converse of the bisector angle theorem, if a point on the interior of the angle of an angle bisector, if that's true, then it is going to be equidistant from the sides. So the distance from C to D and C to B are going to be equal, and therefore to solve this problem we can then set up that DC is, or like this, DC is equal to, well, let me say this, BC is equal to DC, and BC is equal to 4x plus 8, and DC is equal to 9x minus 7. Well, we need to solve for x so that we can find BC. We'll substitute what value we find for x into this equation right here, and that should give us the measure of BC. All right, so let's see. Well, I like to always put the variables on the left, even though it's going to give me a negative, I see. So let's subtract 9x from both sides. And let's subtract 8 from both sides. That's going to get our variables all on the left and our constants on the right. So let's see, 4x minus 9x. It's not going to cancel, but it is going to give me negative 5x. 8 minus 8 is going to cancel. Over here on the right, 9x minus 9x is going to cancel, and negative 7 minus 8 is going to give me negative 15. Let's divide both sides by negative 5. And when I do, x is going to be equal to 3. All right, so let's see. We want to find BC. So BC is right here. And so let's plug in 3 into that 4x plus 8. So we got 4 times 3 plus 8. Well, 4 times 3 is 12 plus 8. And then BC is going to be equal to 20. Now, just for fun, let's plug in 3 for x into what we know about DC, which is 9x plus 7. So if I put 9 times 3 minus 7, well, 9 times 3 is 27 minus 7, and it is also, DC is also going to be equal to 20. And we can do this because of the angle bisector theorem and the converse of the angle bisector theorem. You didn't know you were going to have so much fun in this class, did you?